What if everything astronomers told us about this object was only half the story? What if the strange body moving through our solar system is not behaving like a comet at all because something happened deep above the Chilean deserts that forced scientists into a desperate race for explanations? According to raw observational data, the answers are becoming more unsettling by the hour. At the European Southern Observatory's Very Large Telescope in Paranal, astronomers tracking 3I Atlas detected an event that completely shattered our standard understanding of comet behavior. During a routine monitoring window, the object's anti-tail suddenly rotated. It did not shift slowly or naturally. It flipped with stunning precision. Officially, the event was described as a harmless morphological change, just another visual curiosity in astronomy. But researchers studying the raw telemetry knew this was far more serious. The anti-tail had shifted by exactly 127 degrees relative to the solar vector, placing its orientation directly toward the inner solar system and dangerously close to Earth's orbital zone. Under normal conditions, a comet's tail forms because solar radiation pushes gas and dust away from the sun. The process is simple, understood through centuries of study. Ice heats up, material evaporates, and the solar wind carries it outward, creating a glowing trail. Even anti-tails are usually explained through simple geometry. As Earth crosses the comet's orbital plane, perspective creates an optical illusion that makes dust appear to point toward the sun. It is supposed to be perspective, not structure. But 3I Atlas refuses to fit that model. As scientists analyzed frame by frame, structures erupting from its nucleus began to resemble something far more organized than passive outgassing. The coma showed violent cyclone-like turbulence. The tail itself did not spread into a smooth cloud of debris. Instead, it fractured into dozens of narrow streams that researchers are calling spider jets. These jets erupted from specific points on the nucleus in sharply focused bursts. And this is where the concern truly begins. Several of these jets were firing directly toward the sun itself. That should be impossible. Solar radiation pressure should overpower and scatter any material attempting to move in that direction. Yet, the jets maintained their structure and advanced against forces that should have destroyed them instantly. That single observation changed the conversation entirely. Once an object resists solar pressure in a controlled, sustained way, astronomers can no longer explain it as ordinary comet activity. What they are seeing resembles directional thrust, controlled asymmetric ejection, and a process far closer to active propulsion than passive sublimation. Specialized observatory networks quickly began comparing independent data sets. Spectroscopic analysis revealed unusual material densities inside the anti-tail structure itself. Instead of fine dust particles, the anti-tail contained heavier, concentrated objects moving together in formation. Researchers cautiously began using a term that immediately divided the scientific community: a swarm structure. Not a dust cloud, not random debris, but an organized swarm. The particles maintained coherence despite forces that should have scattered them across space. Their spacing remained stable, and their formation held together. Some reflected infrared radiation like metallic surfaces, while others absorbed energy in patterns that did not match ice, carbon dust, or any standard cometary composition known to science. The deeper researchers looked, the stranger the object became. The nucleus showed asymmetry, inconsistent with natural heating, displaying brightness fluctuations in repeating intervals instead of random bursts. Even more alarming, every luminosity spike corresponded to measurable changes in acceleration. In other words, every single flare of light was immediately followed by movement. That pattern strongly suggests active propulsion. Chemical analysis only intensified the mystery. Nickel concentrations exceeded normal cometary levels by massive margins, while iron distributions appeared inverted compared to primordial solar system material. Trace spectroscopy revealed ionic states requiring enormous energy processes far beyond ordinary solar heating. Scientists were no longer treating this as a simple comet anomaly. They now faced a deeply uncomfortable choice. Either 3I Atlas represented the most exotic natural object ever recorded, or humanity was observing a phenomenon completely outside current astronomical models. And then came the anti-tail flip itself. The precision of that rotation raised one terrifying question across observatory networks worldwide. What physical mechanism could cause such an exact directional adjustment while simultaneously increasing acceleration output? Theoretical tracking models began proposing a disturbing interpretation. The object may not be drifting passively through space at all. It may be actively maneuvering. If that interpretation is even partially correct, the implications are enormous. It means humanity is not simply observing another comet entering the solar system. We could be witnessing an organized system operating with directional control, internal thermal regulation, and coordinated thrust behavior unlike anything officially recognized before. As investigators pushed deeper into the data, the growing list of contradictions became impossible to explain away, pushing this mystery even further beyond the boundaries of accepted science. The moment researchers stopped treating 3I Atlas like a normal comet, the entire investigation changed direction. Once the anti-tail flipped toward the inner solar system, astronomers were forced to confront a possibility they had spent decades dismissing. What if the object was not reacting randomly to gravity and solar heating? What if it was responding according to an internal system? As observatories continued collecting data, the object's behavior became even more difficult to reconcile with standard celestial mechanics. The swarm structure inside the anti-tail was simply not dispersing the way natural debris should. In every known cometary event, particles released from the nucleus gradually separate based on mass and surface area. Smaller particles drift farther under radiation pressure, while heavier fragments lag behind, causing the structure to stretch apart and lose coherence over time. But that was not happening here. The components inside the anti-tail maintained stable internal spacing, and their angular formation showed almost no measurable expansion. Some researchers compared it to a coordinated cloud moving under a shared organizing principle rather than independent motion. The problem was obvious. Gravity alone could not account for this level of formation stability across such vast distances. Then another anomaly appeared. Brightness fluctuations coming from the nucleus were no longer being interpreted as random thermal bursts. Harmonic analysis revealed distinct timing patterns, with flashes repeating in organized intervals almost like pulses. More importantly, every pulse coincided with slight but measurable increases in velocity. That connection terrified analysts within the tracking networks. If luminosity changes directly correlate with acceleration vectors, then the object is not merely heating up. It is actively producing thrust. The spider jets strengthened this interpretation dramatically. Researchers observed dozens of narrow outflows firing from fixed locations across the nucleus, but unlike normal cometary vents, these jets did not erupt evenly across sunlit regions. They activated from specific geometric points regardless of solar exposure, with some firing from areas receiving minimal sunlight at all. That detail directly contradicted the conventional sublimation model, where solar heating strictly controls outgassing. Ice exposed to sunlight evaporates and creates expanding gas clouds, but 3I Atlas showed something entirely different. The jets behaved independently of solar heating gradients, activating in directional patterns aligned with internal structural axes. It looked almost as if the object contained chambers, vents, or pressure systems beneath its surface. Several jets continued firing directly against the solar vector, forcing scientists to confront what this implied. To overcome solar radiation pressure while maintaining coherence, the internal force driving those jets had to be extraordinarily powerful. The object was not behaving like melting ice. It was behaving like a controlled system. As more spectroscopic data arrived, the chemistry deepened the mystery. Nickel concentrations remained drastically elevated compared to known cometary material, and iron ratios appeared inverted relative to standard primordial compositions. The most concerning detail involved the ionic states detected inside the ejecta. Certain elements appeared energized beyond levels expected from passive solar heating. According to multiple analysis groups, the temperatures required to create those signatures implied internal energy processes occurring beneath the surface of the nucleus itself. Something inside the object was generating heat independently. This realization split the scientific community almost immediately. One side argued that humanity was witnessing a rare interstellar body, suggesting the object contained exotic chemistry formed under unknown conditions outside our solar system where jets, anti-tail shifts, and acceleration could eventually be reconciled through expanded natural models. The opposing side was far less comfortable. They pointed out that every attempt to explain one anomaly created sharp contradictions with another. If the swarm structure was natural debris, why did it resist dispersion? If the jets were random venting events, why did they produce directional acceleration? If the brightness pulses were simple thermal fluctuations, why did they align so precisely with measurable trajectory changes? The data refused to separate into isolated anomalies. Everything appeared connected. The swarm, the acceleration, the jets, the anti-tail rotation, the elevated temperatures, and the internal chemistry together formed what some analysts cautiously described as a unified propulsion profile. That phrase alone triggered immediate controversy inside research institutions because propulsion implies intention. Even researchers who rejected artificial explanations admitted the object displayed coordinated functional behavior. The anti-tail flip especially became impossible to dismiss as coincidence, occurring with extraordinary precision at the exact moment acceleration activity intensified. Theoretical tracking simulations began modeling what kind of mechanism could produce such movement. The conclusion was deeply unsettling. If asymmetric jets fired in controlled sequences, the nucleus itself could generate rotational torque while simultaneously maintaining forward propulsion. That would mean the object possesses the ability to alter orientation deliberately. Observatories around the world were no longer asking whether 3I Atlas was anomalous. That question had already been answered. The new question was far more serious. Was the object accelerating toward the inner solar system intentionally? According to speculative trajectory models, the current path intersects dangerously close to Earth's orbital region within a highly precise temporal window. Analysts stress that no collision scenario has been confirmed, but the consistency of the acceleration profile continues to raise alarms. Then came another disturbing discovery. Infrared observations suggested that portions of the swarm structure reflected energy differently from surrounding material. Some components behaved like metallic surfaces, while others absorbed radiation in ways inconsistent with water, ice, or carbon dust. The diversity inside the swarm implied a layered composition and structural complexity that standard fragmentation physics struggles to explain. Natural debris clouds do not normally organize themselves this way, forcing many researchers into an uncomfortable position. Either they would need to expand natural physics to extraordinary levels of complexity, or they would have to admit that existing models might be catastrophically incomplete. Meanwhile, public statements remained carefully controlled. Official releases continued describing 3I Atlas as an unusual but natural comet exhibiting rare interstellar characteristics, maintaining a calm, predictable, and reassuring tone. But behind closed observatory doors, confidence was beginning to fracture because every new data set pushed the object further away from anything humanity had previously observed. What upcoming telescope observations were expected to reveal could finally determine whether this was an extreme natural phenomenon or evidence of something far more organized moving through our solar system. By the time internal discussions about contact protocols began circulating through astronomical networks, many researchers realized the situation had moved far beyond ordinary scientific debate. The concern was no longer whether the object was unusual, but whether humanity even possessed the language to properly describe what it was observing. Observatories across multiple continents shifted resources toward continuous monitoring. Every new image, spectroscopic reading, and trajectory update seemed to deepen the mystery. What should have behaved like an interstellar comet continued displaying characteristics more consistent with a coordinated system. Upcoming high-resolution observations suddenly became critically important as scientists hoped precision imaging would answer one key question. Was the anti-tail truly a continuous dust structure, or was it made of separate objects moving together in formation? That distinction changes everything. If the swarm proved to be ordinary dispersed debris, many of the extreme interpretations would lose credibility. But if scientists confirmed discrete components maintaining formation over vast distances, astronomy would face an unprecedented problem because stable, coordinated formations require organization. Researchers examining the swarm's internal geometry had already identified patterns that resisted natural explanation. The spacing between components remained strangely uniform, and their relative positions barely shifted despite gravitational forces and solar pressure that should have disrupted the formation long ago. Some analysts compared the structure to synchronized movement rather than random distribution. Then, trajectory models introduced another alarming detail. The object was not slowing down as expected. Ordinary comets lose momentum as volatile material escapes from the nucleus, causing their paths to fluctuate while overall acceleration stabilizes over time. Yet 3I Atlas continued generating measurable velocity changes tied directly to internal outgassing events. Every major brightness pulse corresponded to movement, and every directional jet altered orientation with surprising consistency. The pattern was becoming impossible to ignore. According to independent tracking groups, the acceleration profile looked less like chaotic venting and more like controlled course maintenance. That interpretation created deep division inside institutional science. Some researchers insisted the object represented a naturally occurring interstellar phenomenon unlike anything previously encountered, arguing that extraordinary observations do not automatically justify extraordinary conclusions. History is full of scientific mysteries, eventually explained through natural mechanisms once enough data becomes available. But others pointed out a growing contradiction. Expanding natural explanations to include one anomaly only intensified the next. If the jets were natural, why were they directional? If the anti-tail was an optical illusion, why did spectroscopy reveal dense, coherent structures inside it? If the brightness pulses were random, why did they repeatedly align with acceleration changes? If the object was tumbling chaotically, how did it execute such a precise 127-degree anti-tail rotation? The deeper scientists examined the system, the more coordinated it appeared. Then, researchers studying thermal signatures uncovered another unsettling detail. The nucleus did not show evenly distributed heat patterns. Instead, thermal imaging suggested compartmentalized regions of extreme activity separated by cooler, insulated zones. In simple terms, the object appeared internally structured. Some scientists cautiously proposed that the nucleus might contain chambers or layered regions directing pressure through controlled outlets, pushing the propulsion interpretation even further because organized thermal compartmentalization resembles engineering principles far more than random geology. Publicly, institutions avoided these discussions entirely, emphasizing caution and natural explanations with words like rare, complex, and exotic appearing repeatedly in press briefings. Internally, many researchers admitted they were entering theoretical territory where existing models no longer provided stable answers. Attention then shifted toward timing. Trajectory simulations revealed that the anti-tail flip occurred during a very specific orbital alignment relative to Earth's position and the object's inbound vector. Some analysts began asking whether the maneuver itself had been calculated to maximize visibility from Earth-based observatories. That single question changed the emotional atmosphere surrounding the investigation. Once intentionality enters the discussion, every observation acquires a different meaning. The swarm maintaining formation no longer appears as random debris, the pulsing jets no longer appear as accidental eruptions, and the trajectory corrections no longer appear as ordinary gravitational reactions. Everything begins to resemble coordinated behavior. At this point, even skeptical astronomers started acknowledging a deeply uncomfortable reality. Humanity's current models of interstellar objects may be dangerously incomplete. Whether 3I Atlas is ultimately natural or artificial, it is demonstrating organized dynamics that existing comet theory cannot fully explain. The object continues approaching the inner solar system while scientists struggle to redefine the boundaries of known astrophysics in real time. Meanwhile, Another issue quietly emerged behind the scenes. Several observatory teams noticed that portions of the swarm structure reflected light intermittently rather than continuously, with some components brightening and dimming in synchronized intervals. The pattern was subtle but measurable. Analysts debated whether rotational surfaces could explain the effect, but others suggested the timing resembled signal modulation. No official institution endorsed that interpretation, but the discussions continued regardless. If the object truly contains multiple coordinated components, synchronized light variation could imply communication, energy transfer, or shared structural orientation within the swarm itself. That possibility remains speculative, but the fact that serious researchers are considering it reveals how dramatically the situation has evolved. For decades, humanity viewed the cosmos as mostly passive. Stars burned, planets drifted, and comets wandered through space according to predictable gravitational laws. But 3i Atlas is forcing scientists to confront something entirely different: an active system, a navigating system, and possibly even a responsive system. As the object moves closer toward the inner solar system, a terrifying realization is beginning to spread quietly through parts of the astronomical community. If this behavior truly represents intentional propulsion, then Earth may not simply be observing the object. The object may already be aware of Earth. The moment analysts began searching the pulse sequences for intelligent patterning, the investigation entered territory that many scientists once considered impossible. Up until now, most of the debate had focused strictly on physics, propulsion, thermal behavior, and orbital mechanics. But once the acceleration cycle started showing signs of repeatable organization, the conversation shifted towards something far more unsettling. Could the object be adapting its behavior in response to external conditions? That question emerged after researchers completed a deeper harmonic analysis of the brightness pulses linked to the spider jets. Initially, the pulses appeared random, but when observatories synchronized data sets collected from different locations around the world, repeating intervals started to emerge. The timing sequences were not perfectly uniform, but they displayed structured variation instead of chaos. That distinction mattered enormously because natural thermal venting usually produces irregular fluctuations driven by cracking ice, rotating surfaces, and uneven heating. In contrast, the pulse activity of 3i Atlas showed repeating cycles tied directly to changes in orientation and acceleration. In several recorded intervals, the object altered jet intensity immediately before measurable trajectory corrections occurred. In simple terms, the thrust behavior appeared predictive rather than reactive, and the implication sent shockwaves through scientific teams studying the object because predictive thrust suggests internal coordination. As researchers pushed deeper into the data, another anomaly became impossible to ignore. The spider jets were not only directional, they appeared optimized. Certain jets activated in combinations that maximized rotational torque while minimizing destabilization of the nucleus. According to several computational models, random venting should have caused chaotic tumbling long ago. Instead, the object maintained remarkable structural balance while continuing to accelerate inward, suggesting a level of internal regulation that some analysts compared to a gyroscopic correction system. Others argued the object may contain naturally evolved pressure channels capable of self-balancing motion, but no natural explanation fully accounted for the precision of the anti-tail flip or the sustained coherence of the swarm formation. Then, infrared data introduced an even deeper mystery. Thermal mapping of the nucleus revealed localized hot zones shifting over time, and these regions did not remain fixed relative to sunlight exposure. Instead, they migrated internally across the object's structure. Certain sections cooled while others intensified in temperature with no obvious connection to solar heating angles, pointing toward an active, regulated core operating deep beneath the surface. This continuous thermal migration and precise trajectory control mean 3i Atlas is refusing every category we have built to understand the cosmos, leaving us to decide whether we are watching a new law of nature unfold or standing on the brink of absolute first contact. If you want to stay ahead of the latest cosmic discoveries and unravel the true nature of the anomalies reshaping our understanding of the universe, Make sure to hit that subscribe button, turn on all notifications, and leave your thoughts on 3i Atlas in the comments below.